Let's get started. So excited for this session. This is on LLMs, AI search, and then strategies for how to optimize for the upcoming LLMs and AI search. So I'll quickly introduce us. I'm Ethan. I'm the CEO of Graphite. We are an SEO agency, and we also build SEO tools. And we spend a lot of time building out SEO strategies for companies like Notion, Webflow, Masterclass, Chime. And so we also do a lot of research as well. And so Greg, who leads our AI team, will also be helping me with this talk. And let's jump in. So quick housekeeping for chat is disabled. So for chat, please chat in the Discord channel. And then for questions, we have the Q&A section there. And so then we can answer questions at the end.
Great. Well, let's get started. So there's been a lot of excitement about AI search, AI answer engines lately, and it makes a lot of sense because it's really changing the way that we get information online. So for a long time, the way that we got information online would be to go to a search engine, we search, we click a few links, maybe visit some websites, and hopefully somewhere in all of that information, we find the answer that we were looking for. With AI tools, we can go to an AI answer engine, we can ask a question, read the answer, get essentially a direct answer to our question, and then optionally click some links to learn more. But this is a very different paradigm, probably better overall for users. And so what we're going to talk about today is how we might optimize for this new paradigm of AI search or answer engines. So in particular, we're going to talk about two new optimization problems for AI search. The first optimization problem is we're calling answer optimization. So that's how do I get my product or company to appear in an AI answer? So for example, I'm Chase and I want to get the Sapphire Reserve credit card in the AI answer for a question like, what is the best credit card? The second optimization problem is citation optimization. So that's getting your page to be cited by AI in an answer. And so that's, I'm Forbes and I wrote a guide on what's the best credit card, and I want that guide to be cited again in the answer to what's the best credit card. So in order to understand how we can optimize for AI search, we need to know a little bit about the technology behind it, how it actually works. So obviously, large language models are kind of foundational to this, but there's a new technology called Retrieval Augmented Generation that's being used increasingly, being paired with large language models, especially for answer engines. And what Retrieval Augmented Generation does is it retrieves some extra information that can help the LLM give a better answer. And often that retrieval is done by a traditional search engine. And so, the narrative right now, I think, is that large language models are going to make traditional search obsolete. But what we'll see is that what's actually happening is that answer engines are kind of building on top of traditional search engines. So let's start by talking a little bit about large language models. So as most of you probably know at this point, large language models work by doing next word prediction. So large language models are generating text one word at a time. So for example, let's suppose the model has already generated the best project management tool is, and then there's a blank, and it's going to decide what the next word is. So for example, it might decide that the next word is Trello. And what's actually happening under the hood here is the model is computing probabilities for many possible next words that could occur at this position. And and then it's going to pick one of them. So for example, here, Jira actually had the highest probability, but the one that ended up being selected was Trello. And that's because this is a random selection according to these probabilities. And so this explains why if you ask an AI answer engine the same question multiple times, it may give different answers because there's randomness inherent in the generation process. So how does the model know that Trello is a good word to put here? Well, what's happening is that the model has seen in its training set that the word Trello co-occurs with words that are semantically similar to those in the sentence that we were generating. So for example, Trello has been observed in contexts like talking about Kanban style boards, complete project workflow, best project management tools, best for simple project management, etc. Right. And by seeing Trello many times in the training set in different contexts, it sort of learned something about what the word Trello means and understands that it should have a high probability of occurring in that spot in the sentence we were generating. So that's a little bit of a high-level description of how LLMs work. And then from here, we can start to think about how we might optimize for LLMs. And I'll turn it over to Ethan.
Great, thanks, Greg. So this is a bit about how the language models are working. So how can we optimize for this? And we think that more and more people will be using chat and doing search and discovery on chat. So answer optimization is the new SEO. How do we do marketing and appear and have our products appear in all of these chat conversations that are happening? So first strategy is co-occurrence. And Greg mentioned for Trello, when it co-occurs with project management software, the language model learns that these two are related, and therefore Trello is possibly a good option for that. And so if we want to show up for a question, so we work with a company called Signos, and if we say, how can I track my glucose levels? The more that Signos appears and co-occurs with glucose monitor, the more the language model will predict for glucose monitor, Signos should be the next word. And so the more and more that Signos appears, the language model learns that. And let's go to the next slide. So then it's not just showing up on a single location, showing up on many different places. So ideally we show up hundreds of times for our product and what we want to rank for. So this is for best credit cards. This is searching Copilot, and there's thousands of different articles talking about what the best credit cards are. And so the more that our credit card or our product shows up for best credit cards across all these hundreds of different or thousands of different landing pages, the more the language models will say this is a good answer and this answer has a higher probability. So Greg showed where there are the different percentages. So the number of times we co-occur with credit cards in our particular credit card, we'll get a higher and higher score for that. We'll be more and more likely to show up for questions. Second thing is UGC. So you'll see that Google has talked a lot about using more and more unique content in UGC and forum content. And we think that this will be heavily used in AI answers. So Reddit and Quora are two good examples. Reddit and Quora actually just saw their traffic go way up recently with Google. And this is an interesting example because it's a little bit harder to optimize for, or it's different to optimize for a publisher versus a community. And so here you'll see best credit card is Amex Blue Cash is the most upvoted answer in Reddit. And actually I looked and the Chase Sapphire was not mentioned at all. And so the results were very, very different for Reddit versus published content. Quora is similar. So this is the most upvoted answer and it's all Citibank. Chase is not nearly as high. So perhaps Chase is already building relationships with some of these publishers, but very different data sources and completely different optimization strategies. And then it'll vary by surface. So right now Google dominates search. So if you're doing SEO, it's generally Google, but more and more people are using other surfaces like YouTube, Instagram, TikTok to do search and discovery. And similarly, we think that there are a bunch of other new surfaces like ChatGPT, there's Copilot, there's Perplexity, there's Anthropic. So there's all these different surfaces. So we're not just optimizing for a single place. We're not just optimizing for ChatGPT. We need to think about all these other surfaces that we want to go after. And then we want to think about the many ways that you can ask a question. So SEO historically has been keyword targeting. So there's a single keyword like project management software. And all I care about is what my rank is for that. I want to rank for that. And then Google has shifted to topics. So there's maybe 500 different keywords that are about project management software. But then there's chat, and chat could have thousands of different questions. Like you can ask your own question. You might have personalized results specific to you. So there's more and more variants of the different ways that you can ask questions about the same topic. And so keyword research now becomes question research. Like, how do I research the thousands of different ways someone could ask about what the best credit card is, what the best project management software is. So here are some examples of all the different ways. We actually asked ChatGPT, what are some different ways where we can ask this question. This is also interesting because in SEO, you can get search volume for keywords through Ads API and different things, but how do we get the search volume for questions? Like, how do we know, what's the truth set for questions? And how do we know the frequency of these questions? We're not sure yet, but that'll be interesting. Okay, so then how do we track all this? So we want to know how much do we actually show up for questions. So here's an example, again, for Trello and Notion. We want to make sure that when people are asking about project management software, we show up. And so Greg talked about how there's not a single position or a single answer that's always given. It's a probability. And so similar for tracking. So you don't have a single search rank. I'm not position 3. Rather, what's the percentage of times that I mentioned? And what's the percentage of times that I've mentioned over these thousands of questions? And so then it becomes sort of a distribution or a share of voice type of a tracking versus you rank number 3. Great, and I'll throw it over to Greg.
Great. So now let's talk about retrieval augmented generation. So let's start with some motivation. So large language model answers are as good as the available data. So we'll consider 3 cases. So the first case is, let's suppose that there's lots of information in the training set about the question that we're asking. As sort of an extreme example of this, we could imagine we could ask ChatGPT, what is the capital of California? And the model is essentially always going to get this right. If we looked at the alternatives for the word Sacramento, what else could have been generated there? They'll basically all have probability 0. So the model is essentially certain that Sacramento is the capital of California. And the reason is obvious. It's because the model has seen this fact repeated many, many, many times over the internet, so it can be very certain about it. And kind of more generally, if the model has seen the answer, or there are many answers for the question available online, then the model will generally do a pretty good job of answering those questions. What about when there's not enough information? So this is when large language models are said to hallucinate. Or maybe I think the new term to be family friendly is BSing. When is the model BSing? The model, when the model hallucinates, the reason that it hallucinates is because it does not have enough information. So the example here in the screenshot is the New York Times asked ChatGPT when the New York Times first published about artificial intelligence. And the information to answer this question was not in the large language model's training set. Essentially, this article was not online. So ChatGPT just made up the name of an article and a publication date. And the article sounded plausible. And the publication date even made sense, that it was in the 50s, which would have been the time that the New York Times would have first reported on artificial intelligence. So it made something up, but it made something up that was sort of statistically likely to be similar to the right answer. And in that way, large language models can be dangerous, right? So that's what happens when there's not enough information. The third case to consider is the case when there's bad information. So if there's both good information and bad information, and there's more good information, then just statistically the good information will win out. But if there's only really bad information, then the large language model will tend to trust this information blindly. So the example here in the screenshot is the well-circulated example of Google telling someone they should eat 1 rock a day. And then it turned out that the data that caused that the LLM to say that was from an Onion article, which is not maliciously bad content, but it's satirical content and not really appropriate, for this question, right? So what tends to happen is large language models will trust bad information if that's the information that they're given. So the little information and false information case sort of represent like failure modes of large language models. And that brings us to retrieval augmented generation. So if you use ChatGPT, you'll notice that sometimes it tells you that it searched some extra sites. So basically, ChatGPT went out and acquired some extra information to help it answer the question. And in this case, we asked, what is the best project management software? And ChatGPT said that it searched 5 sites, and one of those sites that it says it searched is actually Microsoft Bing. So it wrote the keyword best project management software 2024, and it searched that on Bing, and it used that information to help improve its answer. And this is actually becoming standard. So all of the different AI search or AI answer engines are starting to do this. And as well as many other applications where trying to apply LLMs, for example, within a company where you have proprietary data, basically giving the large language model access to extra information that's kind of specific to the question is becoming standard. And so what does this look like? So typically you have a question, you put that into a prompt, you ask the large language model, and then you get out an answer. But with RAG, what happens is the question or some variant or rewriting of it also goes to a search engine. And the search engine retrieves some extra data, typically web pages. And then segments of those web pages are added to the prompt. So now the large language model not only gets the question, but it also gets, here is some data that could help you answer the question, and a list of segments of web pages that will help improve the answer. And in this context, we often think about large language models as kind of like a creative, generative thing. But what people say is that in this context, when you give the large language model this extra information, it tends to rely mostly on that information. And so people say that the large language model in this context is operating more as a summarization tool, or a reasoning engine that's kind of synthesizing together all of this data than the kind of creative generative model that we usually think of. And this can significantly improve the quality of AI answers. So the extra data helps when there's limited information or the information is out of date. And although it doesn't directly help with bad data, what it does is it provides a good place to potentially filter out bad data. As I mentioned, the large language model tends to use the information that was given to it in the prompt. It tends to use the retrieval augmented generation data that was provided. And so if when retrieving that data, you make sure that it's high quality and you try to filter out bad information, then the quality of your answers will generally improve. As I mentioned, the large language models tend to become less creative. And the last, maybe one of the biggest things, advantages of this method, is it provides an easy method to do citations. So it can be hard for the large language model to attribute an answer to specific documents in its massive training set. But with retrieval augmented generation, essentially the retrieved documents simply become the references. And so you can use this, you can list the retrieved pages at the end as sources, or you can also ask the LLM to provide citations in line as you're generating the summary. And so going back to the point we made earlier, I think the narrative right now is that large language models are going to make traditional search obsolete, but actually what's happening is large language models with retrieval augmented generation are actually kind of more like building on traditional search, more so than replacing. And with that, I will turn it back to Ethan.
Great, thanks, Greg. Okay, so how do we optimize for RAG LLM search and discovery? So this is an interesting example. We work with a company called Resort Pass, and they help you get passes to high-end spas and pools and rent a cabana at a rooftop and things like that. So Resort Pass wants to make sure that whenever someone's searching for day pass at a hotel, that they're going to show up. And so what are the millions of different questions that people are asking about day passes? We need to start with that. And so again, keyword research becomes question research. So how do we get the millions of questions that people are going to ask? And to Greg's point, this is using, since LLM RAG is foundationally starting with search, similarly, how to optimize foundationally starts with SEO. So in the past, we would do keyword research, and then we would do topic research. What are all the different keywords for how people are searching for day passes? And then we do question research. And a specific example of that here is, Resort Pass wants to show up for a keyword would be day pass West Hollywood edition. So the question version of that, or a question version of that, would be, how do I get a day pass for West Hollywood edition? And this is in Perplexity, and you'll see Perplexity is actually, again, Perplexity is a search engine plus LLM, and you'll see that they actually not only mention Resort Pass, but are basically saying you should go to Resort Pass. So this is the perfect outcome for Resort Pass, where the answer says go to this site and get a day pass there. And we can. So the other thing we can look at is question difficulty. So there's keyword difficulty, which is for the credit card example, that's a really competitive keyword, and might be hard to compete for that. So for Resort Pass, we want to know, well, how hard is it going to be to show up for a particular question? So keyword difficulty becomes question difficulty. Some questions will be harder and easier to compete on. And also, we've done some thought leadership around topical authority. So if Resort Pass is competing for Day Pass Hollywood Edition, they're competing against TripAdvisor. If we go to the previous slide, they're competing against TripAdvisor, and TripAdvisor has way more authority than Resort Pass, but Resort Pass has more topical authority. They're known for day passes, and therefore they're more likely to show up. So as we're thinking about the millions and millions of questions, which one do we want to compete on? We can think about question research. What are all those questions? B is, can I compete for that question difficulty, and where am I topically authoritative for? Let's go to the next slide. So then there's what good content is. And good content in SEO is comprehensive and unique. So if I want to show up for what is an ETF, I want to make sure that the structure of my content is optimized and I contain all the keywords and embeddings. And the more that I have that, the more questions and subtopics that I'm covering, the more likely I am to rank for that. And this is actually pretty similar to what we would look at here, which is, did I answer all the questions that people had? So there's thousands of questions. There's thousands of different ways to ask about West Hollywood Edition, getting a day pass. And so the more that I answer these questions on my page, the better content I have. And so here are a few examples. So one would be, how can I get a day pass? When does the West Hollywood Edition open? So Resort Pass has the hours. Can I get a cabana? Can I get a bed? Can I get something by the pool? So these are all questions. So if I have the answers to that on my page, I'm more likely to show up for that. What's a fun vacation idea this weekend? So the more my page answers all of the thousands of questions that you can ask, the better. And I think that also there's a pretty big competitive advantage. A lot of what SEO people do is just go through hundreds of keywords and try to summarize them. So go through hundreds of keywords for West Hollywood Edition and then summarize the themes. And that's actually hard to do, very hard to do at scale, to go through hundreds of questions and synthesize and summarize them. Then it becomes even harder, because rather than summarizing hundreds of keywords, you're summarizing thousands of questions. You may not even know what the questions are. But if you know what the questions are and you can summarize them, then you have this huge competitive advantage over other people, and you can outrank them. So all of this difficulty and friction around how to build strategies for this is an opportunity for anyone who actually has that information. So there's a big information advantage. Okay, so SEO, so then there's owned versus earned. And SEO traditionally has been owned. And by owned, I mean Resort Pass or Chase.com. I want you to come to my site, Chase.com, when you search for credit card. And more and more as citations matter, then I care about earned as well. So not only does Chase want people to come to Chase.com, but Chase wants the citations to mention them. And so earned media becomes more and more important. And here's an example. Greg was talking a lot about the citations, but citations for Copilot for best credit card is US News and NerdWallet and Forbes and all these. So I care about whether or not only I rank, but whether or not I am mentioned on these citations. Okay, so AI. So then we want to think about not only my product showing up as an answer, like Resort Pass, but citation optimization. So how do I show up in the citations? Let's go to the next slide. Okay, and citation optimization starts with SEO. So which citations matter? And the citations that matter are the ones that are being cited in chat. So, similarly, we can look at what are the citations in ChatGPT, what are the citations in Perplexity, what are the citations in Copilot, and then I have many different ways to ask the same question. So what are the citations for all the variants of that? There's also the case where Greg mentioned that it's the same answer doesn't show up. You can ask the same question and get different answers, and there's some probability for that. So then we want to look at, well, what are all the citations across all these surfaces, across all the multiple times that I asked the same question, about all the variations of those questions. And if we go to the next slide, we can look. So that's similar to the question tracking. It's a share of. Similarly here, it'll be a distribution. So across ChatGPT and Perplexity and Copilot, Forbes and NerdWallet showed up across all these at some sort of frequency. I can re-ask the question many different times. So there's SERP tracking in SEO, which is best credit card, your position 3. But now again, it's this distribution across multiple surfaces with a probability or a share of. And so keyword tracking and SERP tracking becomes this share of for citation tracking. And this is for owned. And so Forbes and NerdWallet would want to know, how frequently am I the citation for this question? And the more that I'm the citation, the better. Then if we go to the next slide, then there's RAMP wants to show up. RAMP wants to be showing up in those citations. So let's say that RAMP cares about showing up for best business credit card. They want to see which citations matter. And again, ask the question hundreds of times, ask the variations, ask it across surfaces. And now RAMP or Brex knows which citations are the ones that matter. And I want to make sure that if Forbes and NerdWallet and US News, those are the citations that matter the most, that I mentioned there. And you can also consider, so let's say that this is more and more important. Then presumably a lot of ad dollars might shift from paid search to the citations. So like, how do I spend money or pay Forbes to mention me? That may or may not bring up quality issues. And we looked at the Reddit and Core example where Chase Sapphire is showing up across Perplexity and Forbes and NerdWallet, but it's not showing up in Core and it's not showing up in Reddit where it was the other credit card. But I think that there'll be a whole affiliate network of people paying these citations to show up for these questions. I have to go to the next slide. So then what are the citations that matter the most? And Google has their expertise, authority, trustworthiness, experience. And this will matter more and more because one reason why is because you're getting a single answer. So this is an example with I have nerve pain in my neck. And so if you get low quality information for that and you get an answer, and the answer basically is stating, I know for sure the answer to this, and here's the answer. And if you have the wrong answer, that's really bad. Whereas a search, Google's saying, here's some options, I'm not really sure, but Google's not putting their brand behind what's being said, whereas chat sort of is. So it's pretty high stakes to get this correct, which means that the source matters a lot more. So basically all these expertise, authority, trustworthiness, these have mattered in the past and they matter even more. And this is an interesting example with Copilot where Copilot knows this is a really important question they know that a doctor should be speaking on this versus someone who's not a doctor. You'll see WebMD and the Cleveland Clinic as citations for that. So these trustworthiness matters a lot more. So the other thing is ads versus organic. And this is interesting. So this is an example where I did a few searches, and basically a lot of the surface area for search is ads or Google's owned products. And more for really high LTV searches, you'll see ads in Google products, and organic has been shifted down. Organic still gets a good amount of traffic, but more and more of the clicks go to ads and Google products. And red is ads and green is organic. And this is okay for search. It's maybe kind of annoying, but it's not a huge problem. But if you ask a chat a question and it's just a big wall of ads, that people will have a lot less tolerance for being bombarded with ads. And so there's a good chance that more and more AI answer questions will be organic. So there might be this big shift where organic is a much larger portion of chat than versus ads, whereas search gets a lot of ads. If we go to the next slide. So just to summarize all that, we think that chat and AI answers, more and more people will be going to do search and discovery there. And a lot of the conversation was about it's completely different from search. But actually, in reality, as we're seeing, search is a foundational component for that. And so SEO is an answer optimization is an evolution of SEO versus being something completely different. And the things that matter now are answer optimization. So how does resort path show up for a question? And then citation optimization. What are the publications that are showing up as the citation? And how can I make sure that my brand or my product is the thing that's being cited? And that's everything. So I included a link here if you want to look at the slides and our company's Graphite. And let's jump into questions. So let's start with John's question. If you're not designing an answer engine, but creating a more typical content search like LinkedIn, does it make sense to explore vectorized searches or stick with semantic searches? Greg, I'll throw this over to you if you're able to answer it.
Does it make sense to explore vectorized searches or stick with semantic searches? I think of vectorized searches as semantic searches. So I'm not totally sure that I understand the question. But I mean, I think in terms of vectorization, so something we didn't really talk about in detail was that a lot of times when people are doing retrieval augmented generation, they're using vector search for this, things like Pinecone. And so they're using a neural network model to embed their content and get an embedding vector, and then they're searching with embedding vectors rather than a traditional search that's based on like keywords and tokens and individual words.
Good question, John. Okay, so I'll jump to next one from Milena. So do we think that search engines will monetize product recommendations? I would say, I think so. And the Perplexity CEO was on Lex Friedman podcast talking a bit about this, and Lex asked him about ads in Perplexity. He basically said, "I'm not sure, maybe." So and again, I showed the example of Google where search, you have a bunch of ads for something like a product search, but I'm skeptical that users will tolerate being bombarded with ads. So maybe they will, but my guess is that more and more it'll be money shifts away from the AI chat and it shifts to the people who are being cited. So the goal of your product showing up is whoever's the citation, I'm going to pay them to be part of that answer. That's my guess. And we'll jump to, actually, sorry, I will sort by most.
I can jump back in on that question.
Yep.
So what I was going to say was that, a lot of times when people are using retrieval augmented generation, they're using vector search, but Google is also using vector search, and Bing and like all of the search engines, like over the last few years, have started to use vector search. So I don't know if there's so much of a distinction between the idea that like for, answer engines, you need to use vectorized search versus, for traditional keyword-based search, you can't use it. In fact, actually, the search engines are using it, and then companies like Perplexity are also using traditional search methods as well as vector search. So I don't think there's so much of a distinction between one or the other that you have to use one for one or the other. Does that make sense?
Yeah, thanks, Greg. So Sajan asked, if the final answer is random, how can SEO be more precise? I think I understand this, but Greg, if you go to slide 17, please. So when we say it's random, it is slide 17. Yeah. So it's random, meaning with this probability. So for project management software, Trello shows up 0.38 with 0.38 probability, 0.41 probability, and the LLM is randomly selecting with those probabilities. So it's not truly random, it's with this probability. And how can it be more precise? It's precise by asking the question many times, the variations, and then you get this probability or frequency that question, or sorry, that your answer is the answer for that question. So that's how it can be more precise. And I will jump to Kathleen. So Kathleen asked, is co-occurrence not the same as traditional keywords? How is it different than adding all the keywords to your metadata and to headlines? So I think it's similar. So if we take the example of Signos and glucose monitor, it's similar in that there are keywords of glucose monitor and Signos. So in that sense, it's keywords. But what's new is that the LLM is looking at many, many examples. So what's the number of times that Signos shows up for glucose? And they're still keywords, but the frequency and quantity of number of co-occurrences matters more.
Yes, and the models understand how different words are related to each other, which the traditional techniques do not. So that's the other big difference.
Yes. Okay, so let's jump to Kathleen. Kathleen asked, what would be the KPIs to track for answer engine optimization? What would the funnel for the monthly report for leadership look like? Yeah, so I think for answer optimization, it would be this, which is so for SEO, it would be here are my top keywords that I care about. What's my rank? What's my search position? And how much traffic am I getting? How many conversions am I getting? So that would be for SEO. For answer optimization, it would be this. So this is the form of your SERP, your keyword tracking. So these are all the questions that I care about and my distribution or share of for showing up for that. So how often am I showing up? What I think is interesting though is that it's harder to track clicks and conversions and do attribution. So in Google, you can see someone came from this keyword and they clicked on something and then they came to my site. But in many of the examples that we gave, there's not a click. So it's zero click questions. And so whether or not, for Resort Pass, probably someone would go to the homepage of Resort Pass and they would have no idea where they came from, or they wouldn't know that the chat had mentioned them and that's where that visit came from. That's where that conversion came from. So I think that attribution and conversion tracking will actually be even harder for chat. And I don't actually know what the answer will be, but I think step one is just it's just understanding how many times do I show up in chat across the questions that I care about. And that would be this example. And then the other example we shared later was citation optimization. So for the questions that matter, that I care about, what are the citations that showed up the most? And then are those citations mentioned in me? Yes, no. Marion asked, where can I actually do this tracking? Basically, no one's doing this. And we are building, we're going to build this tracking. We're working on that right now. So that should be open probably in a few weeks, but basically it doesn't exist right now. So we're building that out as part of our platform. So we have a whole SEO platform where we power a lot of the strategies and do like topic research, things like that. So we're basically adding more and more tools, and this will be a set of tools that we're adding, which is this tracking stuff. So no one yet, but we will do that soon. Okay, so moving to Shreyas, who asked, is this suggesting that we beef up our FAQ pages? I think so. If we go to the slide with Resort Pass, slide 27. So I wouldn't say maybe we optimize for FAQ pages, but it's more so that all of the landing pages should know the questions that it has answers for and maybe have FAQs. So for the Resort Pass page on West Hollywood Edition, we need to make sure that we're answering all these questions. That could be in the form of FAQ. That could be for, what are the hours? It doesn't have to be framed as an FAQ, but it needs to be on that page. And the answer needs to be able to grab that. So it's basically saying, what are all the questions that I need for each landing page? So question research, and rather than content research, and then create content that answers all those. And every single landing page that we want to rank needs to answer these questions. So it's not a separate FAQ question. It's basically the entire SEO or the entire answer optimization strategy is a set of what am I answering all the questions? What are the questions I want to answer, and am I answering them? Okay, so I'll go to Pedro's question. How does training windows, i.e. the frequency with which AI companies update their models, play a role in co-occurrence in this optimizations in general? Yeah, so this is an interesting question. Greg looked at the question of who won the Super Bowl, and it was recent, and it looked at ChatGPT did not have the latest information about who won the Super Bowl, and so the answer was out of date. And for something like that, for next word, out-of-date content is going to be a problem. This is actually part of why RAG LLM is better, which is because search has the latest information. So search can look at that information. It can be recent, and then that can feed into the model. And then you don't have this bad time window case. Greg, I don't know if you want to add anything to that.
Yeah, that's right. This is one of the big motivations for RAG, because retraining the models with fresh data all the time is still very expensive. Yeah, it's one of the main motivations for using RAG, to get up-to-date information for timely questions.
So let's move to Asaf's question. Do you generate the questions with LLM? And so this is basically, how do you do question research? So how do we even know what the questions and the variants are? For SEO, you can use Google Ads API, and you can use our platform. There's other keyword research tools, and those are known. So we actually know the keywords that are being searched for, and you can also look in Search Console to see what the keywords are. For for answer optimization, that's not the case. At least that's not the case yet. So where's the truth set of the questions? And an option would be to generate the questions using an LLM. So I actually looked at this for ChatGPT. What are different ways to ask what the best project management software is? And then it gave me a set of questions. That might be a source. However, does the AI actually know whether or not those are the questions that are being asked? Maybe, maybe not. I don't think we know yet. I think, probably how we're starting to think about this is the keywords that you want to rank for are probably pretty good inspiration for the questions that would be asked. So you could sort of transform keywords into questions. But this is something that we're still researching. I don't know if you want to add anything, Greg.
Yeah, you said exactly what I was going to say. So
great. And then Bernice asked a similar question to what we talked about before. So are there tools to track all this? And again, the answer is there's not. And so that's why we're building our own version of that, and that'll be added to our platform. So not yet, but coming soon. And if you want, you can sign up on our site, graphite.io, and submit something. And then if you give us your email, we'll email everyone when we have that live. Okay, last question. Ben asked, it seems like the number of occurrences favors incumbent products. Is time decay or growth factored into determining relevance? Yeah, so Forbes and NerdWallet are showing up a lot, and Chase Sapphire is showing up a lot. So it's all skewing towards top brands, and therefore, it's hard for anyone to compete. And it's just a small set of incumbents, which is bad. And Google specifically does not want Wikipedia and Amazon to be the only sites that are showing up. They want diversity of the search results. So how do we solve for that? I think one way that we solve for that, or that they will solve for that, is to use UGC. So use Reddit, use Quora, and things like that. In terms of recency, similar question to what Greg had mentioned, that ideally search engines are taking care of this for you for the time decay issue, and then the LLM is the summarization of search. So ideally, search is taking care of this time decay or growth factored stuff.
Yeah, I also think with RAG, there'll be more opportunities for sort of non-incumbents to make it into the AI answer, because it's easier to be one of the 5 pages that's retrieved as additional context than to have some large percentage of the entire internet, which is what the model gets from its training set.
Thanks, everyone, for joining. Thanks, everyone.